Chapter 7 Mensuration Exercise 7.1 Fourth question. A right angled triangle PQR where angle Q is equal to 90 degree is rotated about QR and PQ. If QR is equal to 16 cm and PR is equal to 20 cm, compare the curved surface areas of the right circular cones so formed by the triangle. So here we are given with the triangle PQR with the right angle at Q, and the length of PR is equal to 20 centimeter and QR is equal to 16 centimeter. So using Pythagoras theorem, we have to find the length of the line segment P and Q, that is PQ. So using Pythagoras theorem, PR square is equal to QR square plus PQ square. So PR square is equal to 20 square is equal to QR square is 16 square plus PQ square, which we have to find. PQ square is equal to 20 square minus 16 square. So now we have to take square root on both the sides. So when we take square root on this side, the square will go off and we will be getting a square root term on the right side. So PQ is equal to square root of 20 square minus 16 square, which is equal to 400 minus 256, which is equal to square root of 144, which is equal to 12 centimeter. So we get the length of PQ to be 12 centimeter. So first we'll see the rotation about the line segment QR. Okay. So let this be the line QR. So this is our axis QR, and the other case is that PQ as the axis. PQ. PQ. We'll have something like this, and here we have R. Okay, now we are asked to rotate about this axis and this axis. So when we rotate it about this axis, we will be getting a cone like this. We'll be getting a cone like this. So for this cone, this is our L and this is our R radius, this is our L, this is our radius R. So now we are asked to compare the curved surface areas of both these right circular cones so formed by rotating the triangles that is given, right? So the CSA formula for this cone is pi R L, so which is equal to 22 by 7 into, what is this radius? PQ 12 into, then length RP is nothing but 20. Okay, so we have it there. So this is CSA of these cone, the cone formed by rotating the triangle about the QR axis. And next one we have the CSA is equal to pi RL, which is equal to 22 by 7, and its radius is QR is 16 into 16 into what we have, PR as the L, PR we have it to be 20. Okay, yeah. Now on simplification, we have the CSA of the cone formed by rotating the triangle about the QR axis to be 754.28 centimeter square, and for this it is 1005.71 centimeter square. So what do we infer from this? They have asked us to compare, right? So the cone that we have formed by rotating the triangle about the QR axis, we are getting a smaller CSA when compared with the cone formed by rotating the triangle about the PQ axis. We have this 754 and 1005.71. We clearly observe that 1005.71 is greater than 754.28. So we can conclude our answer stating that the CSA of the cone when rotated about PQ is larger than the cone CSA of so we can conclude our answer to be like CSA of the cone when rotated about PQ is larger than the CSA of the cone when rotated about QR axis.